Now we are going to start with a new unit, that is the motion. So first of all, that you should know that what actually is the motion. So see, we have two terms, one is rest and other is motion. Right. Suppose I have a book lying on the table, so I just put the book on the table, and after some time when I look at the book, it remains at the same position. It doesn't change its position with respect to the surroundings. So I say that that book is actually at rest because it doesn't change its position with respect to surroundings, so it is said to be at rest. Likewise, you have bed, you have a table, you have chair in your room. So until unless you move it, otherwise if you keep at certain place, it remains at the same place. It doesn't change its position. So we say that all those things which do not change its position with respect to surroundings, they are actually called to be at rest. So what is rest? Rest is that when body doesn't change its position with respect to surroundings. With respect to means that if we compare it with the surroundings, then it is said to be at rest, right. For example, I write here a book lying on a table. And now what do I mean by motion? Suppose if I am standing here for a particular at a given time, and after a few time I see that I move to this point. So that means I change my position with respect to surroundings, or I am changing my position with respect to surroundings. So that means I will be said to be in motion. So what is motion? Motion is that when body changes its position with respect to, that means as compared to surroundings, then it is said to be in motion. For example, car moving on a road. Car moving on a road. So it is said to be in motion. So this is what is rest and motion. I think you got it, because these are the specific things which we are going to discuss in this chapter. So rest is that when body doesn't change its position with respect to surroundings, and motion is that when body changes its position with respect to the surroundings. For example, book lying on a table doesn't change its position, so it is said to be at rest. And a car moving on a road is constantly changing its position with respect to surroundings, so it is said to be in motion. So this is what is the rest and motion. Now, what are physical quantities? What are physical quantities? See, physical quantities are those which can be measured, which can be actually measured. And you know that we express the physical quantity in two things. One is the magnitude and other is the unit. Suppose I go to market and I ask for 2 kg onion. I don't say that give me 10 number of onions or give me 12 onions. I say give me 1 kg onion or give me 2 kg onion, or like that. So here the 2 means the magnitude and kg refers to a unit. So likewise, every physical quantity possesses a magnitude and a unit, because they are all physical quantities. So whenever we are going to measure physical quantities, we are going to measure them in the magnitude as well as a unit, and a similar way is used to express them. Right. So these are what is the physical quantities. Now we see that physical quantities are of two types generally. All the physical quantities, they are classified into two categories. One is scalar, other is vector. So we say that all the physical quantities, they are just classified into two categories. One is scalar, other is vector. Now, which physical quantity is said to be scalar? Scalar one is that which express, or you can say the physical quantity which is expressed in terms of only magnitude. That means we don't specify any direction, we just specify the magnitude. And vector quantity is that which is expressed in magnitude as well as in direction. So the quantity which is expressed in magnitude as well as the direction is said to be a vector quantity. For example, I say 2 kg. So I am just specifying the magnitude, I am not specifying that north, south, east or west. So that means that is a scalar quantity. But if I say I travel 2 meters towards north, so what I am specifying? I am specifying the magnitude 2 meters, and I am also saying that I am moving 2 meters towards north. So that north is my direction. So I am specifying the magnitude as well as direction. So that means that given quantity is a vector quantity. So scalar is that which is expressed in a magnitude, vector is that which is expressed in a magnitude as well as in we specify direction. Scalar quantities are denoted by a symbol, like all quantities are, but on vector quantities we put arrow. Suppose this, if we write a symbol and on symbol we put the arrow. Arrow means that it is going to occur in a particular, or we can say it is going to occur in a given direction. This is what is the arrow means here. So this is what a scalar and a vector. Moreover, if we say that scalar quantities, they actually can't be plotted on graph. They can't be plotted on graph, but vector quantity can be plotted on graph. They can be plotted on graph. This you will understand in the higher class. And for now, if we look for the example, so scalar quantity, for example, we have distance, right? Or scalar quantities we have area, we have volume, right? So in all these cases we don't specify the direction, but vector quantity like displacement, we have velocity, we have force. So like this we have many you can say physical quantities as vector quantities. So now as I have told you about distance and displacement, so first we are going to discuss that what is actually distance and displacement. They are actually very important, though they look like similar, but actually there is a lot of difference that exists between distance and displacement. So one we have is distance, other we have is displacement. Now what is that? See, suppose there are 3 friends A, and this I am plotting their houses. They are actually not nearby, little far from each other. So suppose I say that A wants to go to B house, but the A doesn't know that where is B situated. So he first goes to a C house, then both the friends go along to a B house. So what happens, suppose A wants to go B, but A doesn't know that where B reside. So A first go to the common friend house, that is at C. Suppose we say it is 4 kilometers from the place, and both then again go together at B house, let's say 3 kilometers. So this the distance which the A will travel will be AC plus CB. That means it is 4 plus 3, that is 7 kilometers. So what is distance? Distance is total path travelled by body in any direction. Here the direction doesn't play a role. So the path actually travelled by the body is called as the distance. So here the total distance is 7. But if I say that A knew if we say that A actually know the house of B, then he doesn't want, then he would have not gone to the C house, he would have gone directly to the B house. So that means if A was aware of the B house, so he must have gone straight to his house, and let's say the distance between the A and B is 5 kilometers. So that means here he is going to follow a one direction route, and this will somehow be less as compared to the total path which he travelled when he went to a B house, C house, and they both then went together to B house. So here AB means the displacement. So what is displacement? It is shortest route, as you can say this is shortest, this comes out to be 7 and this is actually 5. Shortest route travelled by body in given direction or in a straight line or in a particular direction, whatever we can use the term. So total path travelled by body in any direction is distance, and displacement is the shortest route travelled by body in a given direction. So here we see that distance, that means distance doesn't specify the direction, so that means it is a scalar quantity. But displacement occur in a given direction, so it is a vector quantity. How we are going to denote it? Obviously both of them are denoted by S, but whenever you denote S like this, that means it specifies distance, and when you put arrow on it, it means it is a displacement, because we know that in vector quantities we put arrows, right? And we have seen that distance can never be 0. Distance can never be 0. Suppose a body is travelling, so any body which moves do not cover distance in order of 0, or we can say it can never be 0 or negative. We never say that we have travelled minus 5 kilometers. We don't do that, right? Or we cannot do that actually. We say we travel 5, 2, 10, 20, that means in the positive figures. So that means distance can never be 0 or negative. But displacement can be 0, can be positive, can be negative. Now when it is said to be 0, suppose if I move, suppose I am standing here, suppose if I move from here to this place, right, and then I turn around and move to the same place, so that in that case my displacement is 0. So whenever body starts from a specific point and returns to that given point, then its displacement is said to be 0. Or I can just explain you with a figure. Suppose one body starts from this point, cover a certain distance, and then returns to the same point. So that means the displacement is going to be 0. So in the same way, negative 1. Suppose if you are travelling a distance like this and your final point is on the left side, then your displacement is actually negative. So this is what is the distance and displacement, and moreover we can actually, like if I wish to calculate total distance, so how I calculate it? By just adding them. So total distance can be calculated by simply adding, but total displacement can't be calculated by same manner, because we can actually add the magnitude, but then what about direction? We cannot say that north plus east comes out to be west. So that means the direction, the total displacement cannot be calculated by simply adding, right? So this is what is the distance and displacement. And if we talk about the units are actually exactly same. Smaller units is meter, bigger unit is kilometer, and even its smaller unit is meter, bigger unit is kilometer. The difference lies only in this case that it cannot be 0 or cannot be 0 or negative, but it is scalar vector denotions, and moreover it can be in any direction and it occurs in a given direction. It is a long route, that is a short route. So this is what is the difference between distance and displacement. Now we are going to study more terms.